We're going to give PetDog another attribute besides name. We want PetDog to know its location. For any attribute that you're going to use in your class, it's a good idea to create a safe default value for that attribute in the constructor. So for our location, let's say our dog always starts in the doghouse. So now we've defined a new attribute for our dog, location. And we're going to go through a couple iterations of accessing and changing this location before we really get it right in an object-oriented sense. Now, you're going to see a lot of Python programs access these attributes directly, like this. So I'm referring to the object myDog and asking for its name, also referring to the object myDog and asking for its location. Let's run this code. I can see Fido is in the doghouse. This works, but it's not really true to the object-oriented idea of encapsulation and abstraction. However, you'll run across a lot of Python code that accesses an object's data directly. And Python is very permissive compared to other languages in that it won't prevent you from doing this. We use the underscore in the attribute name to indicate that we mean for this data to be private to the object, that we shouldn't be accessing it directly. And in fact, if we look carefully, we see that mydog._name is underlined with a squiggly beige line, which means that PyCharm thinks there's something wrong here. It's a warning saying we've tried to access a protected member of the class. The underscore is indicating that it should be protected. We need to provide a layer between the client and the class data, and we do that with something called an accessor. In other languages, we create methods with the word get at the beginning, like getName, and we simply return the protected variable. Similarly, we can define a method called getLocation that simply returns the location. Now, instead of accessing the class data directly, we use the method getName to access the name, and the method getLocation to access the location. We'll run this again. We have the same result, but this time we've created that layer of abstraction that is in line with the principles of object-oriented design. More importantly, we might want to provide some protection when the client tries to change some of these attributes. For instance, maybe the dog can only be in the doghouse or the kitchen. If we're allowed to set the data directly, we could say something like mydog.location equals the bedroom. Of course, my dog is not allowed in the bedroom. But if I run this, Python lets us change that attribute directly. What we should do instead, just like we used get to access the data, we'll use set to change the data. So we'll create what's called a mutator or a setter called setLocation. Our setter this time will take an argument. We'll simply call it location. It won't get confused with the internal variable location because it doesn't have an underscore. It's going to be a local parameter, and we'll simply set our attribute to equal that parameter, location. And now, when we want to change the location attribute, instead of accessing it directly, we'll use the setter. We say mydog setLocation, and in parentheses we'll say the bedroom. We run this. It still works exactly the same because we haven't yet provided any protection inside the setter. Let's go ahead and do that. If the client asks the setter to use one of the allowed locations, then the setter will update the attribute underscore location to the parameter location. So as long as the client has passed one of the locations that's allowed, the setter goes ahead and sets the attribute underscore location to the location that was passed. Let's specify that that should be a string. But if the client passed anything else, we should raise a value error. Now let's try this, running one of the allowed locations. Everything's fine. Let's replace the allowed location with the bedroom again, and we get an error. So we've provided a little protection to this attribute. Now that we've provided getters and setters for our class, we're really coding true to the object-oriented design.